Now let's talk about question number 17. The question states that if the line y is equal to mx plus c is a common tangent, so this is a problem which is based on common tangent to the hyperbola, and also it has been given the circle here. Can you see that? This is the circle we have, x square plus y square is equal to 36. Now, when you talk about the common tangent, that means first of all, let's understand what are the slope form of the tangents for both hyperbola and circle. That will help us because y is equal to mx plus c is given. Slope is involved here. So that means y is equal to mx plus minus under root of a square m square minus b square. This is our equation of the tangent to the hyperbola. Then we have y is equal to mx plus minus a under root of 1 plus m square. This is nothing but the equation of tangent to the circle in slope form. So that means if I talk about this part, both the things are going to be the same because we have the same tangent. So what we can do, we can just equate it. So we can just write it in this way. If we square it, we can write it a square and this is 1 plus m square, right? So what we can do, we can just substitute the values here. A square is 100 for hyperbola, this is m square, and then we have b square, that is 64. Here the a square is nothing but we are talking about the radius part, which is 36, and this is 1 plus m square. So once we solve this, we get m square is equal to 100 upon 64. So once we get m square is equal to 100 upon 64, we can just put the values here itself. So what we get c square is equal to, say, a square 1 plus m square, right? So this is the circle I'm talking about. So that means c square is coming out to be, a square is what? 36 we have. So 36 times 1 plus 100 upon 64 we have. So just simplify this part. Once you simplify, we get this expression to be the correct one. So friends, let's talk about the next problem, that is question number 18. This is a problem based on indefinite integration, and you have been given the integral as cos theta divided by 5 plus 7 sin theta minus 2 cos square theta d theta, and is equal to a log base e b theta plus c, where c is the constant of integration we have, and we have to find b theta upon a. So friends, what we have a very simple concept used here, the method of substitution, and the spatial integral has been used. So that means if I talk about this part, we can just write this integral as cos theta whole divided by, we convert this cos square theta in 1 minus sin square theta, right? This is what we can do, and this is d theta. So this can be written as cos theta d theta whole divided by, we have 2 sin square theta, then we have plus 7 sin theta, and then we have plus 3. So sin theta can be taken as t, and accordingly we can solve this using the spatial integral form. So if you have an idea of the spatial integral form, you can just solve it. This is a basic problem we have already done in class 12th CBSE level problem, right? So once you use the spatial integral, you will get the third option to be the final answer. That means the value of b theta by a will be 5 2 sin theta plus 1 divided by sin theta plus 3. The spatial integral will be used here. Now let's talk about question number 19. If you see here, the derivative of tan inverse under root of 1 plus x square minus 1 upon x with respect to tan inverse twice of x under root of 1 minus x square upon 1 minus 2x square at x is equal to half is what? So these are the 4 options which are given to us. So here, yes, because this is an inverse expression, so we can just simplify this. So there are 2 substitutions need to be done. One is x is equal to tan theta we can write, and let me take this expression to be, say, u, and here what we can take this as v, and here we can write x is equal to sine phi. So these are the substitution we can do. So once you do the substitution, what we have, we can just simplify the facts, right? So that means u is equal to, we have tan inverse 1 plus x square, that is tan square theta, we have sec theta minus 1 upon, we have tan theta, right? This is what we have, and this can be written as tan inverse. So this is 1 minus cos theta upon sin theta. So I think this is a very simple calculation we have. We have tan inverse tan theta by 2. So theta, what we have taken tan inverse x. So this is coming out to be tan inverse x upon 2 we have, right? Similarly here also the same thing. We have been given x is equal to sine phi. So v can be written as, yes, this is tan inverse. We can just write 2 sine phi cos phi, 2 sine phi cos phi whole divided by 1 minus 2 sine square phi, which is cos 2 phi we have. So 2 sine phi cos phi is sine 2 phi. So that is tan inverse tan 2 phi we have, right? And this is 2 phi. So 2 phi means, yes, phi is sine inverse x we have. So accordingly we can find du by dx divided by, we can find dv upon dx. So this is the final answer we have. And the option number 3 at x is equal to half seems to be the best option we have, right? The correct one, third one.